Good morning, everyone. It's very excited to be here with you guys, and this is the first MUM in Philippines. We're excited to get, I think, more people than we expected. Okay, my presentation today is about high availability IPSec connection. It's probably not a very sophisticated presentation, but I do hope that from this presentation you might get something new, or probably some inspiration on how to create a high availability in your own company. So allow me to spend some time to introduce myself. My name is Herry Darmawan. That's my picture. The real one looks like more good looking, isn't it? Okay. What I do now, I'm a trainer in Belajar MikroTik. So it's a company based on Indonesia. We are conducting MikroTik certified training all over Indonesia, as well as in some country like Philippines, Malaysia, and Australia. And I also one of the consultant engineer at Duxtel Proprietary Limited. It's a company based in Australia. We have a good relationship with the owner, so every time you got clients that need to do something remotely, usually he will contact me, and we'll do it by remote basis. And also in United Plexus, I'm also one of the consultant engineer. I help them in some consulting case in networking. And also I'm a technology consultant at Harvel Corporation. It's actually a company in Indonesia. So we do mostly in technology, including networking, a server basis, and including the solar panel solution, and energy solution. Well, in MikroTik, I use MikroTik since 2004. At that time, MikroTik is using version 2.7 something. And then I become a certified consultant since 2007. Become a certified trainer since 2007 as well. And get, well, it's not all certification at that time, but along the way, we get all the certification that we need to teach MikroTik. And since 2013, I also become a certified academic coordinator. Means that our company supports some academies, some university and high school, vocational high school, to implement MikroTik into their curriculum, in how to teach MikroTik to their students, and how to use MikroTik to learn more on the networking, because they can really touch the hardware, not only the software. Okay, that's about me and about the company where I work for, Belajar MikroTik. Belajar actually it's the Indonesian term for learn. So Indonesia, Belajar MikroTik means learn MikroTik. It's established in 2013 by some independent trainers. I'm one of them. So we are pretty new in a training business, even though me myself has been a trainer since 2007 at my previous company. We have 4 certified trainers, and I think so far we are the only training center with 4 certified trainers. So we conduct a lot of trainings in Indonesia. Averagely, I think around 2 or 3 trainings each month. And we have co-trainers all around Indonesia as well as Philippines. So co-trainers for us is like we try to encourage people to teach MikroTik. We who knows, probably they will become the next trainers. Okay, so we build trainers. We build a community of co-trainers. And we also joined partner with more than 10 company or individual all over Indonesia, as well as Malaysia, Philippines, Timor-Leste. Last month I went to Timor-Leste. It's East Timor in Indonesia. And to my surprise, the one who invited me there is a Filipino. So there's a lot of Filipino also in East Timor. And as well as Australia, we conduct training all over the countries. And The reason why we I might show you some statistic. We have trained more than 600 people in 2014. The reason we can train that many people is because we have a lot of partners in different area. And if you want to see our statistic, you can go to mikrotik.com, training partners Asia, Indonesia, or Asia only. It's all the same. So this is the statistic based on a MikroTik, based on what the participants rate us as a trainer. So we have 4 trainers, we have all the certification, and that's our ratings per December 2014. Okay, and about what we do in Philippines. In Belajar MikroTik in Philippines, actually we start in 2013. Up until now, we already conducted 4 MTCNA, 2 MTCRE and 1 MTCWE. Total around 42 students. And this is our first training in 2013. In fact, the first training that we ever conduct is in Philippines. So we have historically we have a background relationship with United Plexus. This is our first training. Some of you actually attend the MUM, and this is our training on March this year, and also on March, and this is our last training. So you see that previously we don't do selfie, but our last training we do selfie, right? I heard that Philippines is the most selfie country. Yeah, good. So we learn how to do selfie. Okay. Last week we have 11 MTCNA, MTCRE all passed the exam. Congratulations for you guys. And if you are attending this MUM, you can take the certificate at United Plexus booth. And more classes to come. We plan to have in April or May next year. The class probably MTCNA, CCWE, MTCTC. So if you are interested, go to the United Plexus and tell them what class are you interested in. Now about our mark of our footsteps, where we have visit and what we have conducted. This is some area that we conduct our training in. A lot of area in Indonesia, some in Philippines, some in Malaysia, and some in East Timor. Okay, and along the way we also have some future plans about what we are going to do, especially in Philippines. First is the more training classes in Philippines, hopefully not only in Manila, maybe in another area if we get enough participants. Providing solution for clients on consulting basis. That's what we do in Indonesia. We have a consulting company and we would like to extend it in Philippines. And in-house team in Philippines. Currently we are building up a team, a technical team in Philippines, consulting team, so you will get more closer in-touch person that can support you. So in any of your networking problem, if you like our help, you can contact United Plexus. Okay, I think that's all about, not all about the presentation, it's all about the introduction only. So here comes the case that I would like to present. It's about high availability IPSec connection. Well, this case is based on one of our clients. I cannot tell you who the client is, actually who the clients are. Some clients actually use this system. So the concept of this high availability IP security is that it's for company with branches all over the world. Well, it could be in all the area, could be all over the world, wherever they are, and have more than one internet backbone at the headquarters. So at the time when we proposed this POC, this proof of concept, we said that in order to get a high availability, you have to provide two links, two backbone links. And then we do a proof of concept. We make some small simulation that I will show you, and then there goes the project. The tunneling method it's being used is IP security. Well, we have a reason to use IP security. I will explain to you. Now, the initial state that we see in the clients is there are two routers at that time, non-MikroTik routers. So there are two separate routers connected to two different ISP, and if they want to go to another ISP, they change the IP of the laptops. So it's not very convenient for them. And then most of the branches has public IP, most of them, but some only has a local IP because lack of ISP support for some area, because the area could be very remote. And then no live backup router means that if one of the routers like fail, then they need to replace the router. They don't have the live backup routers that can immediately take over the traffic. Okay, so from this starting point, we propose some network solution, and here it comes. First, why IP security? Because IP security is not proprietary. So if for the case maybe they currently have a connection with another brand, so they don't need to change all of them at once. We can do it step by step. IPSec known as the most secure tunnel with lots of encryption support. So you can have a lot of encryption choice. And encryption made inside the router, it's routing based, so it's no virtual interface created, and then can be routing or can be tunnel. And in IPSec, both ends must share the same settings. Means that if for some reason the credential is leaked, okay, if for some reason the credential is leaked, another party must register himself to the router. They cannot just simply create a server, create a client and point to our server. So that's why we use IP security. It's more secure than the other, compared to the other. Okay, here's, in case you don't know about IP security. So here's how the IP security works. So IP security, unlike the other tunnel method, in another tunnel method, you might create one interface, one single interface. In IP security, what you do is you route the traffic. You route the traffic, the router will encrypt the traffic and send it over with a different IP address, not the original IP address. And then once the other router receives the packet, if the packet with IP security, then it will unpack the packet. Okay, so both of them must use the same configuration, they must agree about what kind of encryption they want to use. They must agree about how many encryption level they need to use. Otherwise, they cannot unpack it. So it's much more secure than the other. So in a packet flow point of view, this is how the IPsec looks like. So when the traffic comes in, there's a routing decision. Before it goes to the router, there's a question here: is it IPsec policy or not? If it has an IPsec policy, then it will decrypt the packet, go back to the routing decision, and then send it back to another. Most probably it will send it here. Okay, if you still get confused about this diagram, then you need to see my other presentation a couple of days later in Indonesia. But it's in Bahasa, sorry for that. Okay, now when this is when it got the traffic. When you want to send the traffic, it will come from this side. There's a routing decision. It's an output rules. Okay, and then before it goes out, it will ask about whether this is an IPsec policy or not. If it has IPsec policy, before send it out from the router, you need to encrypt it first. Okay, so it's not like a regular tunneling method where you create an interface and you send something through that interface. It's totally different. Okay, then because of this, we got a challenge. Okay, now before we create an IP security, we have to create a peer. We have to agree each other. What is your IP? What is my IP? Then we need to agree what port are we using. Okay, and then we need to agree what is the proposal check. What is the hash algorithm? What is the encryption? If one of them failed, it means if one of them is not similar, not the same, then you won't get any IP security past your router. Okay, so it's very secure in term of, well, you have to register your clients, not just dial, you get an IP and so on. Okay, and then once you create an IP security, you have to create a rule. Which IP goes to IP security? Which IP goes to the internet regularly? Okay, so there's a source address and destination address, and then if it's match, if this IP want to go to this IP, both are locals, and then change them to another IP based on the IP security. Okay, so this is how IP security work. This is how IP security work. And then, based on this kind of information, we propose a new system. The new system will have a single gateway with policy routing. Means that they don't have to provide two routers with one backup routers. Instead, provide one routers with one backup routers. That's all they need. And then the second system we proposed is the manual load balance IP security. Load balance manually. Because in automatically, well, we might found some issue when the link is intermittent. Okay, so it's a manual load balance. You choose which branches goes to this ISP, which branches goes to another ISP, and then we provide a failover. Means that when we decide, okay, we have 3 clients go to ISP number 1. When ISP number one fail, then it will automatically goes to ISP number 2. That's what we propose. And then the last one, we propose a failover router. So instead of just failovering the backbone, we said, okay, you have a one backup router. We create it as a live backup router. Means that when the main router fail, then the backup router will take the role immediately. Okay, then of course we have another challenge for that. So this is the topology for our proof of concept. So hopefully you can still see the color. Okay, the color means that this branch will connect to this link. It's supposed to be green. Yeah, it's green, right? Okay, and there are another 2 branches go to this link. Okay, that's the idea. That's the idea. Okay, what we want is that when this failed, then those 2 will connect to this green one. That's what we need. That's what we told them. Okay, system number 1. Oops, sorry, too fast. System number 1 is about single gateway policy routing. So instead of using 2 router and need to change your laptop gateway, we propose them, okay, let's use 1 router and we create a policy routing for that. Okay, now we have a policy routing means that, okay, if these branches will go this way, these branches will go this way. Okay, it's a regular policy routing. This is how you can do it in MikroTik. Okay, in MikroTik we have a route list, and then we have an address list. We assign this IP belongs to ISP number 1. This IP belongs to ISP number 2. Okay, and then we mark the routing. If the output goes to IP that through ISP number 1, then we send it with the routing mark via ISP number 1, which is in our routing table. It will have this corresponding routing mark. Okay, so all set. If I want to go to the IP that belongs to ISP 1, that I send it to ISP 1. That's all. It's set. Okay. And then this is how the peer configuration, IP security peer. So we exchange the IP. I want to connect to this IP, and this connect to this IP. That's all. Okay. If you need to set up the IP security, all you need to do is swap the IP. You exchange the IP. I put your IP in my site, you put my IP at your site. Okay. Now this is the peer configuration. This is via ISP number 1, only 1 client. Via ISP number 2, there are 2 clients. Okay, in my headquarter, I need to create 2 peers. Okay, so system number 1 Clear and go. System number 2, how to create a failover for those clients. How to create a failover for those clients. Okay, let's see. Well, the question is, well, this is the question, how to create a failover for this. Okay, I will show you what our team has going through and why we choose the concept that we proposed. First, we were thinking about creating a script. We were thinking about creating a script. Means that, okay, if I cannot reach this, then I will need to change manually. So I use a script to ping regularly. The problem is the script cannot detect if something happens in the middle. So if something happens in the middle, means that even though I move it to here, it won't connect. And it's pretty slow because the script cannot do it real time. You need to have a delay, 5 seconds, 10 seconds, and so on. So that's our concept, going there, going here. Okay, so the clients will dial, and then if failed, client will dial. But it takes too long. So no, we're not going to use this. The second trial from my team, okay, let's create a tunnel. So instead of creating 2 IP security peer, we create a tunnel before we create the peer. If you connect the peer, we create a tunnel. Okay? So the tunnel will go this way. If it fails, then go this way. Okay? But still, the problem is they don't have any IT guy on the remote side. Means that if it fails, then it needs to be manually assigned to one or another ISP, then they give up. Okay? So we think about another way, which is, okay, instead of, normally what you do is your server is in your headquarters, right? Your server is in headquarters. But what we do then is then, okay, we totally change the concept. We put the server at the client side. Means that the client will not do anything, they are waiting. The one who dialed is the headquarters. That's against the normal rules, but it worked for us. So, for example, if this is supposed to go to the second ISP, or first ISP, okay, the green ISP. When the green ISP fails, then it just simply reroute. If, for example, the system failed to do the automatic, for example, maybe the blue one also maybe the problem is in the remote side. So even though you go for the ISP1 or ISP2, it's still disconnected. Okay? So you can manually shut it down, shut it off at the headquarters. You don't need to call the branches to turn it off. The branches will be waiting. Okay? There's the concept. Then we think that's okay. Then the question is, what tunnel do you want to use? Well, you can probably use any tunnel. But our choice goes to SSTP. Our choice goes to SSTP because of some reasons. Maybe you don't agree with this, it's okay. But that's what we choose eventually. We use SSTP because it's pretty fast. And it uses SSL port 443. Mostly all the ISP will not block that port. But if your ISP is not blocking GRE or PPTP, you can use PPTP. Okay? UIP cannot be used. UIP cannot be used because we need some tunnel that we are dialed to. We don't need to provide any peer configuration at the remote side. The remote side will be very passive. That's what we want. Okay, so here's the final topology. So we have tunnel IP, okay, we dial to each of the branches, and then from there, we create the IP security based on the tunnel IP. And yes, so this goes to the green branches, blue branches, and the blue branches. So we think that's okay. That's okay. Okay. So how's it looks like in a MikroTik? So this is the route. This is the routing. Okay. And then you have a to make it easy. We have an ISP, we have a destination IP, that's the IP of our branches. And then when we create the username in our branch, we are going to use their IP address as the username. their IP address as the username. This concept is easier for the next step actually. We have another next step, then we are going to use this configuration to make it easy. Okay, so they provide a username which is their address. But the password, of course, you can change the password. Okay, so this is the HQ side. So the HQ is basically just a client, SSTP client, all clients. So you dial everything, you control everything from the headquarters. Okay, this is the peer configuration. You can see later on. I will provide this PDF to MikroTik so you can download later if you need references. The third system that we offer is a failover. So once we have a load balance, we should have the failover. Means that if one gateway goes down, then you need to be able to go to another backbone. Okay. So add one routing table for the backup. So in MikroTik, this is how it looks like. If you see here, we have an ISP number 1, ISP number 2, and another ISP number 1 and number 2. But if you see the destination, if you group this together via ISP number 1, it has two routing. First is going to IP 10.431 and the other is 172.24.8.9. Can you see that? Once this IP failed, then this will take over. The same thing will happen with the ISP number 2. I have two exactly the same destination, but with two different gateway. When this failed, then this will take over. Okay, here's the idea in how you do it in MikroTik. Okay, then next, but we encounter a problem like this. Okay, let's see when the blue ISP off. Okay, we mark it as red. Then automatically it will go to the green one, and then this will become the green link. Comes from the Ethernet, the green upstream, the green backbone. Okay. Now the problem is when this link comes back, the client is convenient enough not to change the link. Okay. So what can we do about that? So the problem is when the failed link become reactive, the link is not getting back to the previous link. Why? Because nothing's triggered them. Nothing's triggered them. Now the one thing that can trigger them is by checking whether the blue link has been active or not. Then if we know that okay, the blue link is active again, what can we do? We disconnect them so they move back to the blue one. Okay, so we are going to use NetWatch. There's a tools in MikroTik called NetWatch. NetWatch will ping regularly to some IP, and then it can trigger a script when the IP up or when the IP down. In our case, when the IP down, it will do nothing because it will be taken over by the failover script. Okay, if it's up, then I would like to restart the tunnel. So once you restart the tunnel, then the tunnel will go back to its original station. Okay, that's the idea. Now this is the script. Well, the script basically is looking for the address list. Remember about the address list? Okay, the address list ISP1, and then it will look at the address list, and if it matches the ISP1, then what it does, it is the script will take the IP, and it will restart the SSTP client. It will disable. Well, you cannot do a restart in tunnel. All you can do is disable the tunnel, put a delay for 3 seconds, and then re-enable the tunnel. So once it's re-enabled, it will go back to the original link. Okay, and since this happens very fast, then it won't be any problem. This is some screen capture about the POC when we do it. This is the via address list, and that's all. And then the system number 4, we provide them. Okay, I can make you a two router. One as a live backup. Means that if the main router somehow failed, then it will be taken over by the backup immediately. We are using a system called VRRP. Are you familiar enough with this? Filter Router Redundancy Protocol. Now what VRRP do is basically create a virtual IP in the interface. So it creates a virtual IP. So your gateway is actually a virtual IP, not the physical IP. Okay, it will have two router, both have the same IP, same virtual IP, but only one of them active at the same time, if you configure it properly. Otherwise, you will get an IP conflict. Okay, it works in very responsive way, very responsive way. Okay, there we have a two router, two links, but again, we encounter some problem. The problem with it that we encounter is, you look at this. We can virtualize the local IP 10.1 because we have a lot of IP. I can use this physical IP 10.100, 10.200. Okay, I have a lot more spare IP. But the problem is, if you see this IP, I only got one IP, 10.432/30. Okay, in VRRP, normally what you make a virtual is your local IP, local interface. Okay, but you have a public interface that it cannot be swapped and change another IP. Cannot. So, and the second case is how you synchronize the configuration. For example, if I change something in here, do I need to change something in here? Well, the customer will not like that. What the customer wants is, if I change something in here, automatically the backup will update. Okay? So the solution for this is to create a script or scheduler. So about the first problem, /30, what we finally do is we are creating VRRP for all the interface. So the VRRP is not only for the local interface, but for all the interface. So public IP also got a VRRP. But you have to be very careful in conducting this. Because if you fail to do this, then your local IP will active in the main router and your upstream can active at the backup router. It's a mess up. So be very careful. Okay. And then how you synchronize the setting? Okay. The way we synchronize the setting at that POC is that we are creating a script. We need to make an agreement with our customer. Okay. You do not change, you do not make a like unplanned change. Means that if you want to change, you must tell us what kind of changes are you making. For example, okay, I'm adding a new IP for the branches, or I am creating a new routing table. I'm adding a new a backbone. Okay, you tell us, and we are going to create a script that we can take all the configuration. And then at the backup, we are creating a script to fetch the file, because MikroTik have an FTP client. So I can make a script to FTP to that main router, grab the file, and then run the file at the backup. Well, of course, it cannot be done real time, but you need to make a schedule. Maybe once a day, once a day, twice a day, 5 times a day. Okay, so that's basically what we offer to them, and I think at that time VRRP is not getting through, only up until the backup link. Okay, thank you for your attention. For question and contacts, you can email me. You can call me on my phone number, but it's not a Philippines number, so you better send me an email. If you have a question, then I will answer your question. Quick question. Is there any question? No? Okay. If there's no question, then I will give the microphone to the next presenter. I do hope you enjoy my presentation, and well, wish you have some insight or idea about what you want to do with your networks. Okay? Thank you for your attention. It's very happy to be here, and I hope you enjoy the MUM.